On this Ram 1500 with the 3.6 Pentastar, P0354 points us at the primary control side for ignition coil 4. In plain language, the PCM may not be seeing the coil 4 control circuit behave the way it expects. The driver may only notice the MIL, but the engine can also act like it has an ignition miss depending on when the fault is active. Broadly, this can involve the coil feed, the coil control circuit, the spark plug and coil assembly, connector condition, or in some cases the PCM-driver. For this fault, the monitor runs continuously with the ignition on. The code sets when the PCM detects the ignition coil 4 signal circuit current is less than or equal to 0 amps for at least 1-2 seconds. Start with the basic system checks before going into circuit testing. First, read DTCs in all ECUs and record what is there along with the environmental data. Save the vehicle scan report and the related recorded data. Then erase all DTCs, turn the ignition off for a minimum of 10-0 seconds, turn the ignition back on, and operate the vehicle under the same type of conditions that set the fault. Read the codes again. If P0354 does not return, treat it as an intermittent condition and do not force a hard parts call. If it does return, continue with the diagnostic path. Before testing coil 4 directly, look back at the recorded codes. If there are ASD-related DTCs present, diagnose those first because they can affect the coil feed side. If there are no ASD-related faults, move on to the relay output feed test for the coil circuit. Now isolate the 12-volt supply circuit by disconnecting the component harness connector. Connect the load test tool positive lead to the 12-volt supply circuit at the connector, and connect the negative lead to battery ground or a good chassis ground. Make sure the circuit is actually powered during the test. If the circuit is fed by an energized relay, the relay needs to be on. The load test bulb should be illuminated and bright, and you compare that brightness to a direct battery connection. A load test matters here because we are checking whether the circuit can carry current, not just show voltage with no load. A 3156 bulb has approximately 6.0 ohms of resistance and draws approximately 2.0 amps of current. A high-impedance test light that draws less than 0.1 amps is not enough for this load test. The test light or load tool needs to draw more than approximately 0.75 amps. As an example of why this matters, 2.0 ohms of unwanted resistance in the circuit can make the bulb about 25% less than when compared to battery voltage, with a total circuit resistance of 8.0 ohms. If you need to work at the PCM side, do not probe the PCM harness connectors directly. Use the GPEC diagnostic adapter. That adapter can add up to 1.5 ohms of resistance to the circuit, so keep that in mind while evaluating the test. If the bulb is not illuminated and bright, repair the 12-volt circuit for an open or high resistance. If the fuse is open, check the circuit for a short to ground, then verify the repair. If the bulb is bright, go to the coil control circuit operation test. Next, check the ignition coil 4 control circuit. Use a 12-volt test light connected to a 12-volt source and probe the coil 4K15 control circuit at the ignition coil harness connector. Keep clear of the fan belts, pulleys, and any loose clothing around a running or cranking engine. Crank the engine for 5.0 seconds while watching the test light. If it is brightly blinking, the PCM-driver is pulsing the circuit. So the next check is the spark plug. If the light is on constantly, treat that as a possible short to ground on the control circuit. If the light is OFF constantly, move to an open or high resistance check on the control circuit. When the control circuit shows a good blinking pattern, turn the ignition off and inspect the spark plug. Look for cracks, carbon tracking, foreign material, a gap size out of specification, or a loose or broken electrode. If any of those conditions are present, replace the spark plug. If carbon tracking is found on the spark plug, inspect the ignition coil boot for damage and replace the boot if necessary. If none of those spark plug conditions are present, replace the ignition coil and spark plug. Then verify the repair and confirm the code stays gone. If the test light stayed on constantly during the control circuit test, isolate the ignition coil 4K15 control circuit and check it for a short to ground. The ignition must be off when checking continuity to ground. Disconnect the ECU and every component connector that contains that circuit, then use the circuit path to follow the wiring. Put the DVOM negative lead on a known good ground and probe the circuit with the positive lead. There should be no continuity between ground and the circuit being tested. If there is continuity, repair the control circuit for a short to ground, using inline connectors as isolation points where available, then verify the repair. If there is no continuity, continue to the coil swap step before condemning the PCM-driver. If the test light stayed OFF constantly during cranking, isolate the ignition coil 4K15 control circuit and check for an open or high resistance. The ignition must be off for this continuity check. Disconnect the ECU and the component connector for the circuit. Before measuring the circuit, measure the resistance between the two DVOM leads so you know what the meter leads are adding. Then measure the circuit between the component harness connector and the GPEC adapter at the PCM side. Again, if access at the PCM connector is needed, use the GPEC diagnostic adapter rather than probing the PCM harness connector directly, and remember the adapter can add up to 1.5 ohms of resistance. If the circuit resistance is below 3.0 ohms, continue to the coil swap step. If it is not below 3.0 ohms, repair the circuit for an open or high resistance, then verify the repair. Before replacing a PCM, make sure the ignition coil is not what damaged the driver. An internally shorted or damaged secondary coil circuit may be the cause of a PCM coil driver failure, so do not skip this isolation step. Remove the ignition coil controlled by the driver that's set P0354 and install that coil in another coil location that did not have a fault set against it. Turn the ignition on, erase DTCs, then start and run the engine for up to 1 minute. If the engine will not start, crank the engine 3 times for 10 seconds. Read the codes again. If a correlating fault sets for the new coil location, replace the ignition coil and replace and program the PCM, then verify the repair. If the fault does not follow the coil, continue with connection checks. If the coil did not carry the fault to the new location, inspect the related PCM and component connections. Perform any applicable bulletins first. Disconnect the PCM harness connectors, any related inline connectors if equipped, and the related component connectors. Look for poor connector seating, damaged locks, corrosion, signs of water intrusion, whether seal damage, bent terminals, overheating from poor connection, terminals pushed back in the connector cavity, spread terminals and poor terminal tension. Repair anything you find. Then reconnect everything fully and make sure the locks are engaged. Erase DTCs, test drive or operate the vehicle under the monitored and set conditions, and read the codes again. If P0354 returns after those connection checks, replace and program the PCM, then verify the repair. If it does not return, the wiring or poor connection problem has been repaired. The key on P0354 is to stay in order. Confirm the fault, rule out shared power supply issues, load test the feed, read the coil control behavior, separate plug and coil problems from wiring faults, and only make a PCM call after the coil and connections have been proven. For more diagnostic training, visit stepdiagnostics.com.